Miano, what do you want from me? Miano, what do you want from me, bro? Because surely these TikTok doors can't just be TikTok doors for the sake of TikTok doors. Alright, Mets gamers, I hope we are good. I hope we are really good and we are fighting, eh? It's really tough out here in the streets, isn't it, eh? I hope we are fighting and we are fighting and we are fighting. The battlegrounds, eh? I don't know how things have been. Maybe you guys can let me know how's the writing been going. I know some of you have written papers. Maybe you can let me know which grade. It's been funny for me to see in the comment section. For instance, I'm seeing grade 9s commenting that they wrote the same paper. And mind you, these are obviously papers that were written in previous years. These are not like this year's papers or anything like that. But I'm guessing certain provinces, they don't take the time to set new papers. They just, they recycle old papers, and then they allow learners to write the same old papers that were written in the past. So, for instance, a learner in KZN will say that they wrote a Gauteng paper from last year, which means there's interprovincial sharing of papers, and maybe examiners are feeling that, rather than set a new paper, let's just write a paper that was written in another province. So people think maybe me, I'm sharing I'm sharing papers that ought to be written. And guys, I don't know, but all I'm doing is I'm sharing past papers, and that's what's important. So because from where do people practice? We practice from past papers, right? So we need past papers to practice, and that's the only thing I'm doing. It's the only thing I can do, and that is share past papers with you. So on my page, for instance, there's papers for grade 10s written in the past. There's papers for grade 11s written in the past. Pre-exam papers that were written by grade 10s and 11s from the past. Grade 12 papers written in the past. So yeah, there's value in practicing past papers. It gives you an idea as to what kind of questions you can anticipate, right? So there's value in that. Miano, thank you so much for the finger hearts. I really appreciate the TikToks, the finger hearts, and yeah, all the gifts. Thank you so much. They mean a lot. So yeah, I'm grateful that you guys are finding value in practicing the papers, and hopefully you guys can continue to build the same momentum of practicing papers, guys. Don't take that for granted. But I wish there was sort of like a sustained practice that we could have as learners of not just doing papers when it's nearing exam time, but if we could consistently have a program of practicing just papers even on a daily basis. If, let's say, at school you are covering a certain topic, it should become a common practice that you want to find the papers that have been written on the topics, like especially those past papers. Then you can zoom into the topic and zoom into the questions that were asked around that topic. Do not just be content with doing doing just the exercises from the textbook, although that is good and there's value in that, and obviously you should do that, because when you are learning a new concept, textbook exercises help you get into the swing of things. But what you find is that there seems to be a higher level of questioning when you get exposed to exam papers. So it's very important then to also get into practicing exam questions, you see. Yeah, and we need to adopt that kind of practice. It needs to be all too frequent, because I feel like a lot of you are getting shocked, right, when you write the exams. You get shocked when you write the exam because it's like, the exam. it was too much. But then you try and equate what you wrote in the exam with what you were doing as exercises in class, and many of you may feel like what you did as exercises in class was weak compared to what you wrote in the exam. So we need to make it a common practice. It means to become commonplace that if you are doing a topic at school, do the topic, do the exercises in the textbook and the exercises that your teachers ask you to do, but more importantly, get into the practice of doing exam papers as well. Do not allow a topic to pass by without you getting exposure to exam type questions, you see. Yeah. So for instance, let's say you are a grade 10 learner right now. You are going to be writing paper 2 very soon. So for instance, what topics are covered in paper 2 for a grade 10 learner? And maybe in the same vein, what topics are covered by a grade 11 learner for paper 2, right? I know a bulk of you have written paper 1s this past week, and maybe probably in the week before. And maybe in this coming week, you'll be writing paper 2s for grade 10 and grade 11. And even some grade 12s are writing paper 2s. So in paper 2 for grade 10, what are the topics, guys, that we are covering there in paper 2 for grade 10? What are the topics? What topics are covered there? So let's go says trigonometry. Okay, let's go. Which grade are you in? Are you in grade 10 or are you in grade 11? All right, that would be very important for me to know. So trigonometry, definitely. Analytical geometry, definitely. Euclidean. And yes, so those are the major topics. Trig, analytical, Euclid, right? So trigonometry. Okay. Yeah, if you are a grade 10 learner, trigonometry must be so good, Baba. You must be sweet there, now under trig, what's there? All right, we have our Pythagoras type questions there, our Pythagoras type questions, those questions that say without using a calculator. Without using a calculator. You remember those Pythagoras type questions? They are in need of your attention, those questions. They want you, they need you to be on top of your game. So for grade 10 trig, you have Pythagoras type, those questions that say without using a calculator and with the aid of a diagram. And with the aid of a diagram, those questions. Those questions, they need you. They need your attention, those questions, those ones, and you need to know how to do them. You need to be 100% on top of your game doing those questions. So that's one situation there, all right? Then there is those calculator questions. Okay, where you simply substitute. They will tell you if A is equal to 35 degrees and B is equal to 22, find sine A plus B, in brackets. Those I call the calculator questions because they are simply substitution, and then you have to round off your answer to a certain decimal place. I call them calculator questions. So we have Pythagoras type, we have calculator questions. 3, we have trig equations. Trig equations. And in grade 10, your trig equations are always, you are always limited there in the first quadrant. In grade 10, there's just limitations in the first quadrant. Your answers will never be above. When you are solving for trig equations in grade 10, your answer will always be in the region of 0 to 90 degrees. We are in the first quadrant all the time. Okay, so that's very key. Okay, very, very important. Yeah. Yeah, because I uploaded, and like I said, this is not a lesson for teaching per se. I'm just exposing people to things that they need to talk about, and it's not really, I'm not going to be teaching anything here. That's why. So like I said, Pythagoras type questions, without using a calculator, with the aid of a diagram. Plus I thought it was late anyways as well. People are not awake, but I see there's few people that are awake at this time. Then calculator questions, like I said, there's trig equations, where you are talking about 0 to 90 degrees first quadrant. 4, there is special angles. Special angles, where you have to substitute special angles, and very importantly, special angles, the use of your 90-degree triangles, because in grade 10 it's important to use the 90-degree triangles. You have your 1 root 2 triangle that has 45 degrees and 45 degrees, all right, and then okay, so the 45 degrees, 1 root 2. Okay, and then this one, now I love this triangle, because basically this one, okay, just imagine you had a triangle and all of your sides are 2, 2, 2. So it's a equilateral triangle, in other words. Then all you do is you draw a perpendicular line, and it cuts this side into equal halves. So that means you're going to have 1 and 1. So you have 2, 2, 2. So that means 1 and 1. And remember, since it was an equilateral triangle, it means all your angles are what? Are 60 degrees. But if you cut this angle, which is 60, into half, it means you have 30 and 30. So this is how I remember this one. Okay, and then of course, if you take one right angle triangle and you use Pythagoras, this hypotenuse and that adjacent side, then if you use Pythagoras, you are going to find that this side is root 3. Okay, so that's why you have this other triangle, which is 60, 30 degrees, there's the 90, there was that 2, the 1, and then the root 3. Okay, so like I said, there's the special angles when it comes to trigonometry as well. All right, and these special angles, remember, you need to know for sine, for cos, and for tan. Okay, you need to be able to articulate what the respective ratios are. Okay, does that make sense? So the 45 degree angle triangle has 1 root 2. I mean, that's just it. Okay, and then like I said, the 30-60 degree triangle, okay, like I said, if you first initially draw a equilateral triangle where all sides, all three are 2, 2, 2, okay, grade 10s. Okay, because this here is important for grade 10s to know. The grade 10s need to be able to know these triangles for special angles. Grade 11 and 12 don't really need to know, because the grade 11s and 12s, it's nice for them, they can just use the calculator. But for grade 10, there's a requirement that they need to know the right angle triangle, and then they need to be able to state the ratios in accordance to the special angle triangles. So like I said, the 45 degree triangle, 45 with the 90, that's 1 root 2. And then the 60-30 degree angle triangle, we have 2 in the hypotenuse, we have 1 and root 3 for your adjacent sides, but the 1 is always opposite with 30, and the root 3 is always opposite the 60 degrees. So that's very important. All right, very, very important. So then whenever you are given, let's say, a special angle, they say what's sine of 45 degrees, then which triangle are you consulting? Not this one, definitely, but that one. And what is the ratio that you can see of sine 45? Sine 45, obviously the definition of sine is opposite over hypotenuse, so that means sine 45 is 1 over root 2. You see, so these things are just nice and sweet and quick. The minute they say to you tan of 30 degrees, then you know they are referring to the special angle. Which triangle are you going to consult? This one or that one? Definitely not this one, but that one. So tan of 30, all you simply do is you know what the definition of tan is. SOHCAHTOA. I'm sure all of you are accustomed to SOHCAHTOA. Just this is a mnemonic for you to be able to remember the definitions of the trig ratio. Sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. So if you say tan 30, there's 30 degrees. You look at the angle, then definition of tan, opposite. So what's the opposite side of 30 degrees? It is 1. What is the adjacent side of 30 degrees? It is root 3, the side that is next to the angle. Not this one, because this is not the adjacent side. This is the hypotenuse. Why do we know it's the hypotenuse? Hypotenuse is always opposite the 90-degree angle. Hypotenuse always opposite the 90-degree angle. So that's why we know it's the hypotenuse. Okay. So yeah, tan 30 degrees is actually equal to what? Good evening, cutie prince. Tan 30 degrees is opposite over adjacent. So that means 1 over root 3. Okay. So what I'm saying then, guys, here to you is that we need to know the special angles as well. Okay. Yes, cutie prince, I've been offline for probably 2 weeks or more. Okay, because I remember, guys, that in as much as this is a platform I use to teach, but me is a busy guy. School has me on a tailspin as well. So just as much as you guys are busy with exams, I am busy as well, with preparing my learners at school, and I have to be on the ground. So, and marking as well has me on a tailspin. So I'm just as busy as you are. I'm sure you guys are preparing for other exams as well. You've been preparing for other things. I likewise have been preparing my learners for exams and other things as well. So that's why. So trigonometry, as I said, please guys, know the Pythagoras type questions. The ones that require you to basically answer without using a calculator and with the aid of a diagram. 2, the calculator questions, the ones that require you just to simply substitute values using a calculator. You can find the specific values rounding off to a certain decimal place. 3, trig equations. All right, remember, trig equations, our trig equations require us to find values of theta or unknown angles within 0 to 90 degrees in the first quadrant. We are always working in the first quadrant in grade 10. Then our special angles as well. Simplification involving special angles. Yeah, simplification questions. That could be multiply, divide, addition, subtraction, because all of that is included. Addition, multiplication, basically let's just say BODMAS. Everything that has to do with brackets, division, multiplication, addition, and subtraction. It could be of fractions, it could be of terms, it could be anything, where special angles are concerned. Okay, so our grade 10 meal is very, very, very scrumptious, if you know what I mean. A very scrumptious meal for grade 10, and that's trigonometry. Is there anything that the grade 10s are like, hey, say you are missing one thing when it comes to trig? If you look at the trig type questions, is there anything else that we are perhaps missing under trig besides its graphs? Besides its graphs, the trig graphs, from the basic mother graphs, the three mother graphs, sine theta, y is equal to sine theta. You know, I'm hoping you guys know the angles, the special beautiful angles that come from the trig graphs, because there are special angles that arise from the trig graphs. You know, so for instance, sine of 0 I know is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, and then last, the sine of 360 is 0. So if we are looking at the mother graph for sine, there it is. Oh, mommy, mama. First words out of a little baby's mouth is mama. We call this is the sine graph, it's the mother graph, the mommy graph. And it's amazing how if you know the mother graph, then all the other graphs, they are sort of like really straightforward and easy. Cutie Prince, you are saying you don't know double angle, so you are specifically speaking about grade 12, right? I don't know double angle formula and half angle formula. Okay, so in grade 12 there's double angle formula, double angles, sine 2a and cos 2a, you know, sine 2a and cos 2a. I guess me and you will have to coincide when, so I'm going to have a grade 12 session for you then, you know. Yeah, I'm going to have a grade 12 session for you. Right. So what I want to do now is just turn my attention. Maybe let's see. Let's look at some questions here. There's a grade 10. Okay, let's look at this, guys. I hope it's clear for you. In triangle EFG. So this is for my grade 10 learners, guys. So unfortunately, this is a grade 10 session. Yeah, Cutie Prince, I think I'm going to have a grade 12 session. Maybe let's see if maybe I can do it even in the midst of like tonight. But I want to just do some foundational stuff with the grade 10s, and maybe I'll turn my attention to that. Okay, now you're moving over to physics, and yeah, that's basically, I think you need a certain type of teacher for this, what you are wanting. So in triangle EFG, angle E is 90 degrees. There you see angle E is 90. Look at that that square there that indicates 90 degrees. Angle F is equal to theta. EG, okay, we are told is 2 units. That's EG, 2 units. EF is 3. You can see EF is 3 for real. FG is 13. FG is square root, of 13 units. So we have, really and truly, they've given us everything. Now look what the question says. Write down the values of tan theta. Write down the values of tan theta. Sorry about that. So I was just here, sorry. Had a bit of an intermission there. Forgive me. So I was wondering then, write down the values of tan theta. What would be tan theta, guys? Okay, so theta is here. Okay, and before we even jump into identifying, what do we know for sure when it comes to sides? You see, the 90-degree angle is always opposite the hypotenuse. So we know square root of 13 is the hypotenuse. Like, so hands down, square root of 13 is the hypotenuse, hands down. All right. So this square root of 13 is our hypotenuse because it's opposite the 90 degrees. So Tina, we want the value of tan theta. All right, where is theta? Theta is here. So we already know that this is the hypotenuse. That then means that this side, what is it called, guys? If 90 degrees is opposite the hypotenuse, that means we are done. We know this is the hypotenuse. All right. What is this side in relation to this angle theta? EF is called the what? In relation to the angle theta. What do we call EF? Is it the opposite side or is it the adjacent side? EF. Opposite side or adjacent side? So it's very important that we understand what the sides are in relation to the angle that we are given. Because you see, we are asked what tan theta is, we are asked what cosec theta is, and we are asked what cos 90 minus theta is. So now we need to understand what the sides are in relation to the angle. So what is EF, guys? Hopefully you all understand that EF is the what side? It is the adjacent side, the side next to the angle. Then EG would be the opposite side. And of course, because GF is opposite the 90 degrees, we call this the hypotenuse. So then we come here, write down the value of tan theta. What is the definition of tan theta? According to our trig definitions, tan theta is, okay, so we remember SOHCAHTOA. The TOA part is giving us the definition of tan. Tan is opposite over adjacent. So that means if we come here, tan of theta is going to be equal to opposite side, which is 2, over adjacent side, which is 3. So that means tan theta is equal to 2 over who? Over 3. Okay, and that's it. Tan theta is equal to 2 over 3. 1 mark. Then we come here, 5.1.2, cosec theta. Now what is cosec theta? Cosec theta is what we call a reciprocal function. A reciprocal function. And it is the reciprocal of sine. Okay? The reciprocal of sine. The inverse function of sine. Right. So if the definition of sine we know, okay, and we know what sine is opposite over hypotenuse. That means cosec will be expressed as the inverse of that particular ratio. So that means it will not be sine, meaning opposite over hypotenuse, but it will be hypotenuse over opposite side. So if we are reading cosec theta from this diagram, it means that we are going to say cosec theta is the square root of 13, which is the hypotenuse, over the opposite side, which is 2. So we would say square root of 13 over 2, because cosec is the inverse of sine. Okay, so I think we might as well just remind ourselves. So if sine theta is opposite over hypotenuse, the inverse of sine is cosec, which is hypotenuse over opposite. Please guys, let's know that. Very important. The inverse of sine is cosec. All right. And sometimes when we want to express cosec in terms of sine, we write it as 1 over sine theta. Right? So that's very important, especially when it has to do with trig equations and sometimes simplification. So if we want to express cosec in terms of sine, we write it as 1 over sine theta. Okay? That's why we call cosec the inverse of what? Of sine theta. Then cos theta, which is adjacent over hypotenuse, has a reciprocal ratio of sec. Okay? And sec theta would be hypotenuse over adjacent. Make sense? Therefore, the reciprocal trig ratio would be 1 over cos theta if we are expressing sec theta in terms of cos. Then lastly, tan theta, which is opposite over adjacent, has a reciprocal ratio of who? Do you know the reciprocal ratio of tan? Do we know what the reciprocal ratio of tan is? I'm going to wait for someone to comment in the comment section and tell me what is the reciprocal ratio of tan. Thank you, Prince, Cutie Prince. It's cot theta, and it is adjacent over opposite. But if we want to express cot in terms of tan, then you can write it as 1 over tan theta. This is very useful this year, because when we know this, all right, and remember, this is applicable to grade 10 learners specifically, because in grade 10, okay, limited, we get introduced to the reciprocal ratios. They are used in grade 10, and they are explicitly examined in grade 10. But then in grade 11 and 12, there's like absolute silence when it comes to the reciprocal ratios within the CAPS syllabus in South Africa. I need to be specific about that. Within the CAPS, okay, in South Africa, right? I'm not talking about Cambridge here and the IEB. I'm talking about CAPS within the South African context. Yeah, well, in grade 10, we learn about this. We become silent in grade 11 and 12 where these are concerned. Okay, but grade 10 is very important for you to know, right? These, okay? I hope we are on the same page, grade 10. We are good, ne? Can I move? So if we come back here, cosec theta. Now you know the reciprocal ratio of cosec, all right? We know that's sine basically. But when we express cosec in terms of sine, it's 1 over sine theta. But if we were to write the ratio of cosec, okay, since it's the reciprocal of sine, it means that cosec will be hypotenuse over opposite. So it's square root of 13 over 2. Very straightforward. 1 mark in the back. And the last question says cos of 90 minus theta. Now, in grade 10, right, cos of 90 minus theta, we need to look at the triangle. We have 90, we have theta, we have angle G. That means we can find what angle G is in terms of 90 and theta. Let's go. Angle G plus angle E plus angle F should give me how many degrees if I was to add the angles of those triangles. Angle G plus angle E plus angle F gives me how many degrees if I add the angles, guys? How many degrees should I get if I add angle G, angle E, and angle theta for this shape, which we call a triangle? What is the sum of the angles of a triangle? What do we get for the sum of the angles of a triangle? 180 degrees. So angle G there is unknown to us in terms of theta. Angle E is 90 degrees. Angle F is theta. And we know that the addition of these angles gives us 180 degrees. We know the reason. And we would state the reason, sum of angles in a triangle. Jonga, look here. Look at angle G plus angle E, which is 90 degrees, plus angle F, which is theta, is equal to 180 degrees. So angle G is equal to 180 minus 90 minus theta. What's 180 minus 90? 90 degrees. So therefore, angle G is 90 minus theta. So this 90 minus theta is a representation of the angle G. which is very important to note. Okay, I repeat, angle G in terms of theta is 90 minus theta. All right, angle E was 90, angle F is theta, but angle G we didn't know, so we found angle G using the sum of angles in a triangle, and we know that angle G is 90 degrees minus theta. So that then means here we can fill in our diagram and write 90 minus theta. Here, 90 minus theta. This is the angle 90 minus theta. Then we want now to write down the value of cos 90 minus theta. So do you see initially in the diagram, okay, we did not have this angle, okay, but now we do. So then cos 90 minus theta, we can now say cos of 90 minus theta. Now cos, what's the definition of the trigonometric ratio cos? Cos is adjacent over hypotenuse. So in relation to this angle, what is the adjacent side of the triangle? We are looking at this angle now. We're not looking at this angle anymore. We're looking at this one. The adjacent side of 90 minus theta, of this angle 90 minus theta, is which side? What is the adjacent side, guys? Okay, the adjacent side is, I'm gonna wait for you guys to tell me. The adjacent side of this triangle in relation to this 90 minus theta is, yes, Lerato, it is 2. It is GE. This is the adjacent side in relation to this angle. Okay, thank you so much, Sedi. Really appreciate it. Then, adjacent side over hypotenuse. The hypotenuse side, has it changed? Okay, guys, the hypotenuse side doesn't matter which angle we are talking about. The hypotenuse side is hypotenuse remains the same. It does not change. So the hypotenuse side is still who? It's still GF. So that means we have adjacent 2 over root 13. That's what cos 90 minus theta is. That's why this here is 2 marks, because first and foremost we need to figure out what the angle 90 minus theta, where is that even located first. All right, and there's a bit of work that we need to do in order to do that. We then know that angle G is 90 minus theta. Then after that, we can then look at the trig ratio of cos in relation to the angle, and we say, what's cos of 90 minus theta? It is adjacent over hypotenuse, which means it's 2 over root 13. Okay, guys, so these problems are straightforward, not even a problem there. Let's move here. Now we are here now. Okay, this is what I was talking about when I was saying Pythagoras type questions. Okay, Pythagoras type. Okay, we are looking at this question. It says in the diagram below, PXY is a point in the 4th quadrant. Okay, so what's nice about this diagram is that we are given the diagram. Okay, obviously we know that there's different types of questions when it comes to Pythagoras types. There are questions where the diagram is given to you. There are questions where the diagram is not given to you, and you have to first interpret what is there, and then you have to draw the diagram in the relevant quadrant. So in the diagram below, we are told that PXY is a point in the 4th quadrant. 1st quadrant, 2nd quadrant, 3rd quadrant, 4th quadrant. Okay, so then we have in the diagram PXY is a point where in the 4th quadrant. This is the 4th quadrant. So in our Cartesian plane, guys, we have 4 quadrants. This is the 1st quadrant, this is the 2nd quadrant, this is the 3rd quadrant, and this is the 4th. So we are told in the diagram below, P, there is P, there it is, guys, XY. This P point has a X coordinate and a Y coordinate, okay, is a point in the 4th quadrant. Then we are told angle BOP is theta, is equal to theta. There is angle BOP, which means it's the angle. Now, Please note, guys, what kind of angle this is. If it's coming from here all the way to there, all right, from 0 to 90 to 180 to 270, exceeding 270, what kind of angle is that? Do we know what kind of angle is that? Now I want to check if my grade 8 learners and 9 learners are still living within these grade 10 learners that are here. What kind of angle is this one? What kind of angle is this one? Less than 360, greater than 180. What do we call that type of angle? We call it a what angle? I want to hear you guys tell me what kind of angle is that. I'm listening very intently. Okay. It would be revolution if it was equal to 360, but this one is not equal to 360. It's from 0 to 180 to 270. It's just shy of 360. Greater though than 180, but less than 360. What do we call that type of angle? I need someone to comment in the comment section. Guys, if you can't tell me what kind of angle that is, then I'm very sad. What is an angle? Let's first check here. What is an angle that is greater than 0 but less than 90 degrees? What kind of angle do we call that? We call that a first, let's look at the first question I'm asking. Okay, now you're jumping the gun. An angle greater than 0 but less than 90. You know, if it was between 0 and 90 degrees, what kind of angle do we call that? An angle between 0 and 90 degrees. Very good, Atlechang. Atlechang Mini, you are my star. Atlechang Mini, it's an acute angle. Angles between 0 and 90 degrees are called acute. They are cute, right? Very cute, very cute. Those are the kinds of angles we are dealing with whenever we are finding or when we are solving for x. Okay? When we are solving for an unknown angle and we are solving trig equations in grade 10, all of our angles are acute angles. Okay? Now, what are angles that are between 90 and 180? What do we call angles that are between 90 and 180? Okay, very good, Larat, if you said acute as well. What do we call angles that are between 90 and 180? Your Atlechang is very fast there in the typing. Yes, Atlechang, we call them obtuse. Somila, amazing. Sedi, amazing as well. We call them obtuse angles. Very good. Then, what do we call angles that are greater than 180 but less than 360? Greater than 180 but less than 360. Now I'm going to check who is knowing their stuff, because that's the last bit. Greater than 180, less than 360. We call those angles what exactly? Yes, yes, Khele. Is it Khele or Rele or really? Okay. Sorry if I butchered your name there. Just forgive me. Yes, reflex, guys. That's what I wanted to hear you guys say. Reflex all the way. Thank you so much. Now you are with me. Now we are together, guys. We are together very well. Reflex angles. So I just wanted to, remind us of that. So BOP, angle BOP is a reflex angle. And we are told that 17 cos theta minus 15 is equal to what? To 0. Now, with this diagram that we have been given here, this information has then now been what? Been visually represented in this diagram. Okay? But we need to still what? We still need to populate it with more information so that we can then be able to be in the position of answering the questions that are here. Now look at what it says now. Make use of the information provided and the diagram to determine the length of OP. Now where is OP? This is OP. We are asked to make use of the information provided and the diagram to determine the length of OP. So what I'm going to do for us, I'm going to redraw this diagram so that we can see it more clearly. Now I want you to listen to me and listen to me well. So here we have y, here we have x. Remember what I said, we all agreed that this here is the angle that is referred to as theta. We all agree about that. We call this a standard angle. We can call it a standard angle, okay? Because it is a reflex angle. It's from here all the way to there. This then makes it so that we have remember we have a point here. We called it P. We said it's X and Y, right? What we then do is we complete a right angle triangle in that quadrant, the fourth quadrant, okay? Then we just make sure our 90 degrees is intact because we represent a right angle triangle in this quadrant, all right? Then there was an equation that we had, which was 17 cos theta minus 15, which is equal to 0. We need to now express this equation as a trig ratio where cos theta is the subject of the equation. So how do we go about doing that? We are going to apply the additive inverse and the multiplicative inverse to isolate cos theta. I repeat, we are going to apply the additive inverse and the multiplicative inverse. There are how many terms in the expression? On the left, there are 2 terms. So we isolate 17 cos theta and we transpose negative 15 to become positive 15 on the right hand side. That's the additive inverse. Add 15. What we do on the left, we do on the right. We add 15 as well on the right. Then we apply the multiplicative inverse. We divide by the coefficient of cos theta, which is 17 on the left. But what we do on the left, we do on the right. So then that leaves us with cos theta, the trig ratio, which is 15 over 17. Okay, I hope we are together. This is very important for the sketching of our diagram. Even if we did not get given the diagram, getting our trig ratio to be isolated when we are given an equation is so crucial and important, so that from that we can then proceed populating our right angle triangle with both sides and angles. Okay, so let's go. Cos theta is equal to 15 over 17. What is the definition of cos? Definition of cos is adjacent over hypotenuse. But what is the definition in terms of x, y, and r? This is very important, knowing the definition in terms of x, y, and r. So in terms of x, y, and r, it is x over r. That is the definition of cos in terms of x and r. Thank you, Lerato. X is divided by r. X over r, or x is to r. Okay, so that means 15 is x, 17 is r, 15 is x. So remember, we had OB here according to the diagram. All right, we completed our diagram and had a right angle triangle. Then we said isolate cos, make it the trig ratio, and then we have our numerical representation of the trig ratio, which is 15 over 17. Definition of cos is adjacent over hypotenuse, which is x over r. 15 is x. So that means here on the x-axis, the length of OB is 15, right? It is 15, guys, right? It is 15 OB, all right? Because it is the x value. R is what? 17. Okay, and if we can go back, we was told make use of the information provided and the diagram to determine the length of what? OP. Where's OP? There is OP. Didn't we just assign the value of R OP as 17? Yes, we did. Based on what? Based on our trig ratio cos theta, because cos theta is x over r, which is adjacent over hypotenuse, which is 15 over 17. 15 is x, 17 is r, which is OP, because it is r. I hope it makes sense, guys. So from the trig definition, we can just answer that question without even flinching. OP is equal to 17, and we can write 17 units. Okay, but we would be required first to actually make sure we write our equation and make cos theta the subject so that we can see the ratio, which then gives us our x, our r value, and everything else that is missing. Let's answer the next question, 5.2.2. Are we together, people? Do we understand what I just did? Can I move on to 5.2.2? Or is there someone who has a question and I am losing you? I'm losing you, my brother, my sister, my mother, my father, my uncle, my aunt, my grandma, my grandpapa. All right. Silence means we are okay. All right. Lenok Tulani says, please repeat. So in the diagram below, P xy, that's P xy, is a point in the fourth quadrant. P, here is it. It really is in the fourth quadrant. It's a point indeed in the fourth quadrant. B, angle BOP. Where is angle BOP? Angle BOP. This entire angle is equal to theta. We call this angle the standard angle. Okay? Then, and we are told that 17 cos theta minus 15 is equal to 0. 17 cos theta minus 15 is equal to what? To 0. Now the question is saying, make use of the information provided and the diagram to determine the length of OP. Where is OP? Here is OP. It's OP. It is our R value. The hypotenuse or the radius of our unit circle, if there was a unit circle. We call this the radius. It is the hypotenuse. You know, the grade 12s would even appreciate that, oh, this is the radius for our unit circle. Okay. Now they're saying determine the length of OP. So I said we go to the equation. 17 cos theta minus 15 is equal to 0. We come and redraw this diagram, which I did so beautifully here. My y and my x-axis. My OB. My OP, which is my R. I then close my right angle triangle because this is a right angle triangle. include my 90 degrees. Then I need to populate my sides and my angles. So initially, because they asked for OP, the length, I'm just interested to find OP. So I go to my trig equation. 17 cos theta minus 15 is equal to 0. I apply the additive inverse and the multiplicative inverse to my equation, meaning minus 15, transpose it to the right, becomes 15, that is positive on the right side. Then we divide both sides by 17, the coefficient of cos theta. Because 17 is multiplied, I divide by 17 to get rid of 17, both on the left and right. I'm left with cos theta is equal to 15 over 17. Then I ask myself, this 15 over 17, it is what? It is cos. What is cos? Cos is the definition x over r, adjacent over hypotenuse, which means 15 in the numerator is x. There, 15 is my x value because it's on the x-axis. 17 is my r value because it is the hypotenuse. So I populate my hypotenuse with 17. Remember, what did I ask for? The length of OP. So what's the length of OP? OP is my 17, the value that I actually have as my denominator value for cos theta, which is r. There it is. So I say OP is 17 what? Units. Finished. Okay, finished. Then we move on to the next question. Determine the length or calculate. So this time we're asked to calculate the length, the value of tan theta. Tan theta, by definition. So I come here and I'm like, okay, all well and good. Tan theta is equal to. So in my head, I'm like, I know the definition of tan. Okay, tan of theta. It is what? For this right angle triangle, it is opposite, which I don't know what the opposite side is, over adjacent, which is 15. So that means then I need to calculate BP. Hence, the question is even saying calculate the value of tan theta, because they know I am missing a particular aspect of tan, which is the opposite side. So that means BP needs to be calculated. So I'm going to come here and go and write BP squared. All right. Now, first and foremost, it's very important, Pythagoras. R squared is equal to x squared plus y squared. That's the original formula of Pythagoras, because Pythagoras says the square of the hypotenuse is equal to the sum of the square of the other two sides. So r squared is equal to x squared plus y squared. And please, guys, whenever you use Pythagoras, please write the reason just out of habit. Write it there to indicate that you know you're using Pythagoras. R squared is 17 squared, x squared is 15 squared, and the y squared is what you are looking for, right? Which is basically your BP. Then you use your calculator very nicely so that you can basically get your answer. Okay, 17 squared minus 15 squared, you just put that and very nicely in your calculator. Bro, it is 1 a.m. bro. I love these people that come on here. They're like, bro. There it is, guys, 64. Remember? Then you take the square root of 64, both sides. And remember, this is very critical. You put plus minus when you are dealing with an equation having taken the square root on both sides. For the numerical value, you write plus minus. Therefore, that means y is equal to plus minus 8. Meaning it can be a positive 8 or a negative 8. So if you look at the position where BP is located, right, our y value in this quadrant, okay, is supposed to be positive or negative. That's the question. Our y value in this quadrant, is it a positive or a negative value? You tell me. our y value in this quadrant, is it positive or is it a negative value? Okay, Snoop says negative, so does Somila. Sadie, Shady, Mady, Dady, Low Boy, negative. Thank you, guys. So therefore we conclude that y is equal to -8, which is very key for the purpose of our diagram, that it is -8. Any other conclusion would be false and inaccurate. Any other conclusion would be false and inaccurate. So therefore now we are ready to write down our trig ratio for tan, because we have just discovered what our y value or our opposite side actually is equal to. So we say tan theta is equal to what? Do you want to go ahead, take your shot? Tan theta is equal to, this is the opposite side over the adjacent side. So therefore our answer will be -8 over 15. And me being me, I like writing that negative sign, because there's only one negative sign. I write that negative sign in line with the divide sign, just to indicate that at the end of the day, that negative divided by positive gives me a negative value fraction. So it's -8 over 15. Okay, I hope that makes sense for all of you. So that is that. That's 5.2.2. The value of tan theta is -8 over 15. Okay, so my calculation together with the writing of my ratio is basically what validates my answer. And therefore when they say calculate, guys, it actually means I need to show my steps for getting that answer. So this coupled with that would then obviously underscore why I get the marks. Then 5.2.3, the very last question, says the following for grade 10s. Prove that cos squared theta plus sin squared theta is equal to 1. Prove that cos squared theta plus sin squared theta is equal to 1. Guys, when they say prove something generally in mathematics, and I need to make this clear for most learners, okay, this is the question that they are asking. They are saying I must prove it. I have a left hand side and there's a right hand side. My left hand side is complicated. My right hand side is simplified. So it's very important then to take the complicated side. So I will do this. I will say left hand side is equal to sine squared theta plus cos squared theta. That's what we do, guys. Then as a grade 10 learner, you know nothing about anything when it comes to this thing. So therefore you need to really show how this thing is equal to that. So the sine squared theta, you go to your diagram. What is sine in terms of these numerical values? Sine theta here will be opposite over hypotenuse. In other words, -8 over 17. So I go ahead and I say -8 over 17. All right, and then I put this in brackets and I square it. Then I say plus, what's cos squared theta? So let's go and read what cos is. Cos is adjacent over hypotenuse. In other words, it is 15 over 17. Then you put that in brackets and you square it. Okay, then we proceed. When we proceed, we apply the square to both the numerator and the denominator. So you know most, this is 64 over what? Over 289. Plus, do the same thing there. 15 squared, you know it's 225 over what? 289. Then the denominators are the same. In fractions, when the denominators are the same, what do? You add the numerator, which gives you 289 over 289. What's 289 over 289? It is equal to 1. But isn't this the right hand side? Which was 1? Yes, it is. Therefore, you conclude sine squared theta plus cos squared theta indeed is equal to what? 1. Okay. So the question was asking us to prove. So we showed it using the diagram that indeed we do get 1 for our right hand side. Just like our left hand side, we simplified, we dealt with it alone using our diagram, and then we concluded getting the right hand side, which we indicated is, and then we conclude that indeed sine squared theta plus cos squared theta is equal to 1. Was that difficult, guys? Hey, you must say to me. I say it was difficult. You must say to me. I want to hear people say it's difficult. But it was mapena, it was it took us down, it messed us up, it ended our careers, type thing, you know. I need to hear those things. Okay, so we good, ne? Okay. Yes, very easy. You just need to understand what they want. Please, guys, don't complicate life. Yeah, it's very easy, these things. Right, grade 10s, we're still going together. Yeah. Next type of questions, look at this. If x is equal to 15 degrees and y is equal to 22.5 degrees, use your calculator and determine, correct to 2 decimal places, the following. Okay, and there it is. Using your calculator, you have cos to the power 3. Yeah? I just need to make this bigger so that you guys can see it properly. Sorry. Cos to the power 3 x minus sine squared x. Okay, so this is use your calculator, just calculator usage. All right, and you'll be shocked at the marks. 2 marks for this, 2 marks for that, 2 marks for this. But I will tell you now, people lose marks in these things, and I'll tell you why. Because they don't round off properly. Some people fail to round off properly. 2, some people fail to even substitute in the correct way. So the first one, okay, you are told x is equal to 15 and y is equal to 22.5. Let's see. You tell me, guys. I want to see in the comment section. Let me know what 6.1.1 is. What do you guys get for 6.1.1? All right. I'm guessing. I'm hoping you guys substitute correctly. But what do you get for 6.1.1? I'm gonna show you after you are done commenting. Okay, Aura has indicated that 0.89. See my grade 10s, they are working there. 0.89. Let's see what everybody else has. So cos cubed x minus sine squared x, substituting those values, x equal to 15 and y is equal to 22.5. Thank you so much, Mr. TK, TKZ. Guys, Mr. TK, you see that amazing man that's sending some roses there. You guys, your maths and science needs are taken care of in this beautiful platform of TikTok. There's a guy to follow there. I'm sure some of you may have run across his lives. Guy is just sacrificial like nobody's business. Doesn't matter what day of night he's doing the things. This guy is doing the things. During the day he pulls hours. During the night he pulls hours. If ever you are able to get the chance of tuning into his lives, I tell you, he really does do the most. He does the most. You should definitely give him a follow, give him a shout, join his lives. You'll benefit a lot. If you're still a grade 10 learner, grade 11 learner, what I like about him is that he's even more, he's versatile for both maths and science, and he's got like experience for days and knowledge for days to impart, and I think he's relevant. I think even for my Tswana, Spedi, Sotho speaking learners who are, who probably will benefit a whole lot more hearing the vernacular being spoken whilst the math is being communicated. You guys will benefit a lot landing in that platform of his. So please, Mr. TK there in my comment section, guys, give him a follow, and please also join his live sessions. You can check out his page as well. He's uploaded content. He's got a YouTube channel even where he's uploading some of his stuff that he does. Please check it out. I'm Manlerato. Different strokes for different oaks, okay? So some people obviously will benefit a lot from doing that. So please remember, at the end of the day, some of us, we may love eating cheese, but some of us will love our chutney and our sweet chili, and so it's all good. The variety allows people to be able to venture into different platforms and get what they need to get. So that's what's important here, and I love the work that he's doing. Very sacrificial, guys, and he's doing the most. So please give yourselves a chance there. So we were checking out this one, guys. You guys, I'm sure I can see people have commented there in the comment section. It seems like people have come with answers. 0.87 was Aura's answer. Aura then changed to 0.57. Thank you so much, Mr. Tig. Have a brilliant one as well, a beautiful one. Seti saying 0.97. We have different answers. I love this. I love the difference in answers because it means people are applying things in various ways. Okay, so I'm gonna show you just shortly what it is I have done here so that we can all be in the same page. Yabo? Which is very important. Very, very important. Right. So let me just show you. So obviously people here, cos to the power 3, right? It says if x is equal to 15 and y is equal to 22.5, use your calculator and determine, correct to 2 decimal places, the following. So you are told x is equal to 15. So if you look at 6.1.1, there's only one variable that is being expressed in this expression. It is x. There's no y here. So what you are going to be doing is you are going to be substituting in the place of x the 15 degrees for here and for there. All right. And I just want to show you practically actually what this means. So if you have cos x, you could actually write cos x as a trig ratio, and then you could write the exponent external to the trig ratio. So you can express it as such. So this can be cos 15 all raised to the power 3 minus sine 15 degrees all raised to the power 2. And I suppose sometimes this is where, people sort of like miss it a bit, okay? The trig ratio raised to the power 3, the trig ratio inside the bracket raised to the power 2. And then you can punch all of this in your calculator and get the answer. All right, so take the exponent out and then evaluate the trig ratio. So then if you do that, your answer should reflect. Okay, you should have an appropriate answer, no doubt. Surely you must have an appropriate answer. So do we still all get the same answer? You got it right. Oh man. Yeah, so you punch that in your calculator nicely, and then Hi. Mtanom, it should materialize, mtanom, you know? I'm sibohle, guys, I'm sibohle. Right, so it should materialize nice, this thing. Yeah, let's see. Hey, and then this is what I got. What did you get? What did you guys get? I got 0.83 mna. All right, yeah. And then I love the fact that people are asking, should I write degrees? Should I write? Okay, so if I'm rounding off to 2 decimal places, that means 0.8. Remember, 8, the 3, this is where we cut off. We cut off in the second decimal place. Then the 4, we ask, what does 4 say to the 3? This number is 4 and below. So that means 0.83, guys. Right? 0.8 bunny, 83. Right? It's not degrees. Right? It's not degrees. Because remember, if you're substituting x, your output value, which is y, is actually not an angle, right? That's very important. Okay, it's not an angle. So your x-axis oftentimes, will represent your degrees, your input value, but your output is not an angle, right? So even here, guys, please take note, right? Even here, your output, this one, we don't say it's 1 degrees, it's 1. This is 0.83. So we don't write degrees, please. And that's another error that kids make. So this would be units, because it's a measurement, okay? So 0.83. All right. So I hope people are feeling me. We are together. I hope 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 we are together. We are together. Hopefully we are together. Okay. All right. Any questions? Any pressing questions? Are we feeling this? Are we in the same page? Can I get a amen in the comment section? I'm just kidding. But I hope people are with me. It's very important to be together. And I'm telling you, people butcher these things, guys. They butcher these things. People, they butcher. Okay. If people are with me, then we can move on. Let's check this one out. Now we have 5 sec 2y over cot x. Right? Now, the sec and cot are not in the calculator. You don't have sec in the calculator. You don't have cot in the calculator. So what do we do here? 6.1.2. 5 sec 2y over cot x. What do we do here? Okay, hopefully we can see what we can do. So that means we can use our reciprocal ratios so that we can be able to utilize the calculator. So if we have sec, then we can convert that sec into 1 over cos. If we have cot, we can change it to 1 over 10. Right? Yeah, so hopefully we can see that. So I want to see what you guys get. That's why I'm giving you time. I'm not actually moving. Porter says 1.89. This we've got a witness. Seems like Aura is confident this time around, like, no jokes. Like Aura is just like This is it. Booyah. We're gonna see, Aura. I'm coming. We're coming for you again. We'll see. We will see. We will witness. We will witness. We will witness. So I'm giving people a chance so that they can write down and do the things. I need more people commenting in the comment section. My calculator says error. No. Yeah, now you'll see the algebra specialists here, the people who have got algebraic skills, because the algebra will show here. You know, Lerado is like, how did you substitute? My calculator says error. Right, so I'm going to show you here. So here we are, we have 5 sec 2y over cot x. So then our 5 sec 2y, guys, we're going to rewrite it as 5 over cos 2y. And maybe someone is like, huh? 5 over cos 2y? How did? Okay, remember we had 5, right? Then our sec y becomes 1 over cos 2y. Okay? But then 5 times all of this gives us 5 over cos 2y. So that's where this 5 over cos 2y comes from. In our numerator, the fraction is 5 over cos 2y. Over. Then the cot x we rewrite as 1 over tan x. Okay, this is very important. Then, okay, maybe this is a step I need to show, that I can then write 5 over cos 2y divided by 1 over tan 2y. So we can write this 5 over cos 2y divided by 1 over tan x, sorry. Why am I saying tan 2y? Tan x. Okay, so I can write 5 over cos 2y divided by 1 over tan x. Does that make sense, guys? Hope that makes sense. Then remember, with fractions, if you are dividing something, you can change the divide to what? To multiply. So this 5 over cos 2y becomes times this 1 over tan x. I can write it as tan, right? A reciprocal. Tan 15 over 1. So you see now I'm substituting in the place of y 2 times 22, 5. 2 times 22, 5. And then I write times, then it's tan 15 degrees. Okay, so I'm taking this 5 over cos 2 times 22, 5, multiplying it by tan 15. So if you come to my calculator, this is what I did. There it is. 5 over cos 2 times 22, 5 times the tan 15. Okay, and then when I say equal, I get that, which is very messy. And I can write, if they say leave my answer in third form, then I would leave my answer in this third form. But voila, 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 aura, voila, aura. I think aura was voila this time round. So far, blow mama, go aura. So aura got 1,89, which is basically our answer is indeed 1,89. You know, even the calculator validates it as such. So you see now, guys, that we are actually applying our algebraic skills that we learned in grade 7, 8, and 9. Writing fractions, expressing our fractions as fractions where there's a division sign now. We change the divide to multiply so that we can invert the fraction that follows after the change division sign. Division to multiply, that means 1 over 2 tan 15 becomes tan 15 over 1. Okay, and then we can just write that as tan 15, then we multiply those two and we get 1,89. So guys, there's a bit of work then that's required whenever we have a reciprocal of the trig ratio, because we need to first express it in terms of sine and cos. Why? Sine, cos, and tan. Why? Because our calculator does not have sec and cot. It doesn't even have cosec. So then we have to be innovative. How 2 marks? How? Yeah. Sometimes, please don't put too much don't not regard that work as 2-mark work, you know. Yeah. Be chilled. Okay, let's look at this one. Square root of cosec brackets y minus x. Close the bracket. This all under the square root. Okay, you can do this one, guys, as well. Remember, we're still saying x is equal to 15 and y is equal to 22,5 degrees. Use your calculator. Determine correct with 2 decimal places the following. Inditi kala na. Ay. What a song, guys. What a song. Okay. Aura says 1,00. Somila says 2.77. I wonder. Will it be Aura with 1,00? Or will it be Somila with 2.77? Tune in next time as we check it out with the correction. Okay. Oh, Sedi just pulled in a whammy there as well. Oh, Aura just fixed. So it is Somila who seems to be having the answer. But we have another user, 47109, saying 0,17. Could it be that user has discovered an unknown vault? Or could it be that Lerato has rounded off correctly instead of the rounding off of the others? Could it be that, guys? Could it be? Now we'll see just shortly, guys. Oh, Lerato changes her answer there, apologizing most sincerely for her error. Okay. Wowza. This is turning out to be quite an exciting turn of events. My goodness. All right, okay. I'm on Lerato. Lerato, why do you always? It seems like you're always stressing you. It's fine, man. Okay, we it's a game. Please, maths is a game. All right, like we in practice mode here. What you don't want to be doing such in the exam. So let's chill, please. Chill pill. You need a chill pill, Lerato. Okay, so let's check it out, guys. If this works out. So of course we have 1 over sine. The y minus x obviously means y. Y in this situation means 22,5 minus the what? Minus the 15. We can just plug this all in the calculator very nicely, and our answer can be answering. You see? Very nice, very nice. We got the sign there. Got the sign there. We got 22.5 there. We got minus 15 there. We close it up there. And then we just say voila. Yeah, it seems like 2.77 wins the race. Indeed. Okay, there it is, guys. Very nice, very well done. Okay, that wasn't too shabby now, was it? Not too shabby at all, eh? Okay. The trig marks are ours, guys. The trig marks are ours. The trig marks are ours. They are calling us. Okay, let's move on to the solve for x. Okay, I think at 2 a.m. guys, I will lovingly leave you with just having done some trig, and then we'll see when another session can be held. Let's look at this one. Solve for x, correct one decimal place where x is greater than or equal to 0 but less than or equal to 90. X is greater than or equal to 0 but less than or equal to 90. So you can see there 6.2.1 tan 2x is equal to 1,01. What they want us to do, solve for x, correct 2. Please take note of the instruction, one decimal place where x is greater than or equal to 0 but less than or equal to 90. On my YouTube channel, guys, I did a nice beautiful video on these trig equations. All right, I think I piggybacked that trig equation video with some algebra. Okay, so it was like the video where I did trig equations had something else in it as well. I think I did trig equations at the beginning, and I did like a variety, different types of like trig equations you could expect. All right, so please guys, check it out. The YouTube channel, Maths is a Game. All right, Pabalo, username on YouTube, Maths is a Game. The link is in my bio, not the WhatsApp channel but the YouTube channel. But even if you are also subscribing or joining the WhatsApp channel, guys, it helps because all my clickable links for the videos, sometimes I post the YouTube videos there, you know. Also, there is on my YouTube channel, I started a series on on analytical geometry. So you can check out some of the analytical geometry sort of like videos that I did there. And then also I had some live sessions that I had done with people like Lerato that joined in. You can check out real dedications, and you accommodate for the youth in terms of lifetimes. Thank you TJ, for real, really appreciate it. Really appreciate you as well. Thank you for that, whatever. But just understand as well that it's very hard for me. I know some of you like, so why don't you just have set times so that we know when you do live? Unfortunately, I can't, because my time is not, it's not as as set out as I would like it to be. So there are times when I can actually avail myself and I can do something, but then there's times when I can't. So I'm sorry that it can't quite happen the way that we would like it to, whether the schedule. But yeah, my life is a bit crazy. I will have another live session, but it can't be from 9 until 1. When you say live on Sunday, do you mean in the morning from 9 until 1 in the morning, or do you mean late at night for Monday, from Sunday night to like 1 o'clock in the next morning for Monday? Is that what you mean? Because that would be crazy. Unfortunately, I can't from 9 till 1. It will have Sunday, because I go to church, you know. Okay, 6.2.1, but I'll definitely have a session on Sunday. We'll see the time. 6.2.1 tan 2x is equal to 1,01. So I see you guys Oh, you said late at night. Okay, we'll see then. We'll see how we can do that. I'm sure I can fit that in. Tan 2x is equal to 1,01. So I see Lerato said 22,464 degrees. Then Somila said 28,9. Remember, guys, we said solve for x correct to 1 decimal place. It said 1 decimal place. So we need to follow the instruction. Do not follow the instruction. Goodbye, marks. Goodbye, future. Goodbye, everything. Okay. Pablo says 22,7. We'll see. Okay. So hopefully we are doing the steps nicely when we do the trig equations. And I love in grade 10, what's nice is that our x values, we always get one x value because we are working within this quadrant. We are working in the first quadrant. In the first quadrant, all my trig ratios are positive. Sine, cos, and tan are positive. And Lerato, we must not think, we must know for sure according to what has been stated, you see. So I understand that generally speaking, we like 2 decimal place, but then you see if they ask in the question and they specify, we need to subscribe, otherwise we lose marks because we did not subscribe to what was stated, you see. So tan 2x equal to 1,01. What do we do here? We take arctan on the other side and isolate 2x. Okay, maybe someone is sitting there and they're like, so why didn't we just divide by 2 from the get-go? All right, guys, we don't do that when the accompanying coefficient is with regards to the angle and there's a trig ratio. We don't do that. We only do that if there was a coefficient of the trig ratio. If there's a coefficient for the trig ratio, then we first divide by that coefficient of the trig ratio. But if it's the coefficient of the angle, we do not ever divide by 2 at the beginning before taking arctan. We have to take arctan on the right hand side of 1,01. Okay, and then with that arctan of 1,01, we can divide that by 2. Does that make sense? I hope it makes sense, guys, because that's why sometimes people get various answers, because they apply the wrong, or they approach the problem differently, they abuse the problem. Okay, I'm happy it looks good. I hope it looks good as handsome as you are, hustler. I hope it looks good as handsome as you are. You see, it's very important that it looks good as handsome as you are. Because you're a hustler. You're a hustler. You're a hustler. Okay, now I'm Miss BU31. I don't know if I don't know why I'm not. Why not over 2 tan? Okay, why not over 2 tan? Okay, I don't know if I'm losing you. You are losing me there, Miss Boo. Is it Miss Boo 31? 2x is equal to, so what did you guys get for that? Did it get you or did you get it? It's very important to get things, not for them to get you. You must get the answer. The answer must not get you, you see? So if you round off to 1 decimal place, okay, remember that this value that you get in your calculator is this one. Okay, now if you round off to 1 decimal place, we cut off there at the 6. 4, what does 4 say to 6? 22, what? What does the 4 say to the 6? Okay, I hope we all wrote tan inverse 1,01 over 2. What does the 4 say to the 6? We stay the same. You don't change, you don't change, you don't change. And don't forget, this is an angle, so it's in degrees, guys. Hello? The 4 says to the 6, we stay the same. We don't change, look. But if this number was 5, 6, 7, this number 4 was 5, 6, 7, then it would mean that the 6 would go up by 1. But if this number is a 4, 3, 2, 1, then 0, then it means 6 stays the same. So our answer is 22,6 degrees. I hope we are all together there. Next one. Sine of 2x minus 20 degrees. Now the 2x minus 20 degrees, the angle is in brackets. Now everything is divided by 3. That's fine, look, if your calculator says 645. Then at that calculator point, you have the obligation, you cut off the line there because you want first decimal place. You cut off. Then you ask where you cut off, let me just do this. I need to help you understand what one decimal place. You cut off here. Then, because you want one decimal place, then you ask the 4. What does the 4 say to the 6? All right. Okay. So whatever decimal place you want to round off, you cut off, and then this second number then is required to ask, since I am like this, what do we do to you? Since I am like this, what do we do to you so that I can have that single decimal number? Are you with me? Please, guys, you cut off at this point. And then this guy is like, since I am like this, I am 4. What do I do to you? Do I take you up, or do I just keep you that way? There are those friends, man, even in life, that they keep you like that, or they make you rise higher and higher. So 4, it keeps you that way, my friend. You know, there's no change that you'll experience being with 4. But if it was 5, 6, 7, 5, 6, 7 has that impact of raising you higher and higher. So please, guys, let's take note of that rounding off. We don't want to be losing marks because we are inefficient in our rounding off. We must be very effective in rounding off our answers to the appropriate decimal place so that people do not doubt our capabilities. You see, let's go to this one. Solve for x correct to one decimal place. Where? You see, our x value needs to be between this. You see me? So, what to do there? You tell me, guys, what to do there? What a guy. How do we push this one? How do we push this agenda, guys? How do we move from here? Do you get the answer? Is it popping? Is it flowing? Like the water? Keep it flowing, guys, keep it flowing. Is it flowing, kebabas? Ah, look at that blue-faced person. The blue-faced guy. Okay, I'm waiting now for the answers in one decimal place. I will know that people have actually moved when I see the one decimal place answers starting to be posted in the comment section. Where? Yo. This is solved for x, guys. This is just solve for x once again. It's no different from the previous question. Solve for x, correct one decimal place. Same thing. Remember we did this one, solve for x, correct one decimal place. Now we're doing this one, solve for x, correct one decimal place, where x is between 0 and 90 degrees, where 0 and 90 are included. So don't be lost, please. Don't be lost. Don't be lost. Do not be lost. You cannot be lost. We got Mr. Vigorous in the house, in the hizzles. Oh, of course. Of course. You work it out, obviously. I'm sure you have your pen and your paper. You are busy with the question yourself, punching out your calculator. Then I see your comment section answer. The appropriate answer, as you've been doing, my beautiful learners. It seems like you guys are hesitant this time round to actually give me what I want. Magwala. I see there in the comment section, Magwala. Thanks for the follows, guys. People are following like crazy here. Like, I feel like my followers are just rising in numbers. Mr. Vigorous just followed, thank you. I heart Malwandla followed, thank you. Stembi, so thank you. Low key Obi, thank you. Kialabucha, guys. Kialabucha, and don't forget this guy. It helps a lot, you know. This helps me out a lot when you guys help me there. So thank you. I appreciate as well, you know. Especially those that are able. Thank you. Really appreciate it. Helps me with the lives. Sadie says 10,9 degrees. Okay, I'm ready now to take it away, Mr. DJ. Mr. DJ Maths is the game. Take it away. I feel like I'm the Uncle Waffles of like mathematics, you know. People are like, maths game, we wanna do maths. Maths game, we wanna do maths. Alright, okay, so sine into 2x minus 20 degrees in brackets over 3. Now guys, please take note. You see this 2. I said this 2 is a coefficient of x, the angle. So this 2 affects this angle. So we first take arctan, and then we can actually go ahead at the end of the day, divide by 2. Here in this situation, we need to look at those things as well. So this is the trig ratio sine. This is the angle. It's a compound angle. It's 2x minus 20 degrees. So that means we need to wait, you know, arc sine would have to be taken before we even deal with this. But what it is divided by the 3, this 3 has nothing to do with the angle. This 3 is basically a coefficient. And if we were to actually really reveal what it is, this 3, it's actually a fraction 1 over 3. And it's a coefficient of sine. Does that make sense? Yeah. But it's fine if we say this, all of it is divided by 3. At the end of the day, it's like saying 1 over 3. Okay, so that means, you know, if we were to take the approach of, okay, the LCD of this equation is who? It's 3. And what we do is we multiply both sides by what? By 3, so that we can get rid of the denominator. Shortcut is to cross multiply. Somebody said in the comment section, cross multiply. What are we cross multiplying? The 3. We just cross multiply the 3, right? Which is the same thing. It's the same concept. It's just a shortcut. Just like transposing is like the additive inverse. When you take a term and you transpose it to the other side, cross multiplying is like the shortcut for what we refer to as taking the multiplicative inverse. Okay, because it would be like since this is 1 over 3, we multiply by 3 to get rid of the 3. But what we do on the left, we do on the right. Or we just say we cross multiply, which is just the shortcut for multiplicative inverse. Okay, so this 3, like I said, does not affect the angle here. What's here, right? It's just a coefficient of the trig ratio. So we need to first take care of that. So which is why we have sine 2x minus 20 degrees. So we multiply by 3 both sides, really and truly, so that that 3 disappears. We are left with sine into 2x minus 20 degrees, and then we can multiply 0.099 by 3. So we do that, 0.099. We multiply by 3, we get 297 over 1,000. And it's actually fine to leave it in that state, because it's together. The decimals would make things become a bit crazy. Now, what do we do now that we're here? Now we have sine, we have the compound angle. So we can go ahead and take the arc of sine, 297 over 1,000. And then we leave 2x minus 20 to skew. All right, very important. We leave that to skew. So sine inverse of that answer that we had gotten, which was 297 over 1,000, gives us what? That 17,2. Okay, I get 17,277,50495. Okay, I keep that thing in my calculator. I transpose the negative 20 to become positive 20, and then I isolate the 2x. So I just go to my calculator as it is. I add 20 to what is already there, the answer plus 20, which gives me that. That's 37,277,50495. Divide both sides by 2 so that I can see what I'm dealing with. It's in the calculator. I just go ahead, I divide by 2. There's the answer. 18,638. X is equal to 18,63. Okay, I'm just gonna write the whole thing so that I can show you my rounding off. You guys can see my rounding off. Okay, then it says 1 decimal place. So you see where I cut off. We ask him, what do you want to do to 6? Let's keep him as it is, 18,6. And this is an angle, guys, so it's 18,6 degrees. Okay, so Sedi and company, right? I hope, even though you guys see what's happening, I hope you don't lose heart, you don't get disheartened. But more than anything else, it's an opportunity of like saying, oh, okay, now I see. Oh, so I see what Sir did, and I see where I went wrong. So it's a learning curve, okay? And therefore you can then make corrections, course corrections for yourself, and moving forward, you know exactly what needs to be done in a problem of this nature. So then you won't find yourself in a pickle, okay? And that's beautiful, Sedi. That's what matters here. Okay, please guys, don't, in as much as I know we love being right and we love being accurate all the time, especially like in a platform such as this, where it's like there's so many people coming in and out in the live session, and just imagine commenting and people seeing your comment, and then maybe you feel like, I don't like being right in front of a lot of people. But you know what? We are here to learn, and we want to basically equip ourselves sufficiently so that when we write, we don't find ourselves, you know, falling in the same traps. Or so I'm proud of you guys. I'm really proud of how we're going along, moving along very smoothly. All right, so I hope you guys saw those steps. And then this guy, without the use of a calculator, showing all working, determine the value of sine 60 sec 30 plus tan squared 60 over 2 tan 45. And why are they saying without the use of a calculator? It's because they can see that, oh, 60, 30, 60, 45. What do we call those? What do we call those beautiful things? We call them special angles. You see? So because there are special angles in the mix, they know that you can just hop on, you know, and just do your thing. Larato. Negativity aside, please. I don't want that negativity ever. Now we need to not lose marks. It's as simple as that. No need. Losing marks there's no need to be losing marks here. Okay, even if it has been your thing, it has been your bread and butter, losing marks, that's fine, but now it doesn't have to be the case. Okay, so now earlier on I told you we looked at the triangles that we ought to be using here. We looked at them. There's the 45 degree triangle, there is the 30-60 degree triangle. So there we have sine of 60. Okay, the thing is, you'll get penalized, right? If you'll get penalized because there's trig ratios that when you utilize your calculator, what the calculator will do. For instance, if you sine 45, for instance, sine 45, if you use your calculator to get sine 45, you'll get root 2 over 2, whereas typically when you are using the diagram, it's 1 over root 2. So yeah, then because of that, they'll see, oh, you rationalize the denominator, therefore calculator was used for the trig ratios to convert special angles to ratios. So you just need to be a bit wary when you are using that. Okay, very, very wary. Sine 60, sine of angle 60 degrees. Okay, according to so your calculator there will give you the same. Pabalo, it helps. For a grade 10 learner, it's important. But when you are in grade 11 and 12, it's fine. You can use your calculator to basically write all the trig ratios, because in grade 11 they take it that you guys have done rationalizing the denominator, and so you can express your fractions being rationalized. Okay, so if you're in grade 11 and 12, calculator is fine. But if you're in grade 10, there's this insisting notion that you need to use your triangles. So all of those that have a square root in the denominator obviously will need your triangles, but there are those who don't have a square root in the denominator. So a calculator could, no one would know if you used your calculator or you didn't for those. So sine 60, for instance, okay, whether you use the calculator, sine 60 is basically root 3 over 2, right? And even if you put it in your calculator, it's also root 3 over 2. So it's the same. You move on to sec 60, or sec 30, sorry. Remember, sec is the reciprocal of cos. So sec 30 will be hypotenuse over adjacent. So that's 2 over root 3. Yeah, 2 over root 3. Tan squared 60. So you open brackets, you put a square on the outside, and then you write the ratio of tan 60 using your triangle. So tan of 60, if you use your triangle, tan of 60 is opposite over adjacent, so it's root 3 over 1. That's tan of 60, root 3 over 1. Root 3 over 1, and you put the square outside the bracket, over 2. Then we go to tan 45. Tan 45 is simply 1 over 1, which is 1. Okay, so if you write 1 over 1, that's fine, but if you just write 1, it's okay. Then, after you've done all of this, you need to remember this guy. BODMAS or BEDMAS if you want. Okay, so what does this thing BODMAS say? It says brackets, you need to start off exponents. So there's an exponent there. Obviously for that term alone you'll apply your exponent. Division if there is. Multiplication, so multiplication does get priority. So this root 3 over 2 times 2 over root 3, I'm sure you can see here there's something that's going to result. That will cancel. You will be left with 1 and 1. Okay, and then this 2 and this 2 will cancel, left with 1 and 1. So there's an answer there of 1. You see, 1 from this, the multiplication of these two. 1 plus root 3 over 2. If you apply the square to root 3, you get 3. And then you apply the square to 1, you get 1. So it's like 1 plus 3 in the numerator over. What's 2 times 1? 2 times 1 is 2. So 1 plus 3 over 2, you get 4 over 2, which is 2. Okay. So I hope we are together there. Okay, I repeat again. These two cancel, and those you get 1. Then root 3 over 1, you apply the square to root 3, you get 3. You apply the square to 1, you get 1. And this is 1 plus 3 over 1. It's like 1 plus 3. 1 plus 3 is 4. In the denominator, you had 2. The tan 45 was 1. 2 times 1, which is 2. And then obviously that 2, 1 plus 3 is 4. 4 divided by 2 gives us 2. Okay. So the simplification really, guys, is so straightforward. Once you, because like I said, this is a matter of applying simplification from grade what? This is grade 8 and 9 simplification. Once you get here, once you get the ratios substituted according to your triangles, then this is simplification from grade 8 and 9. So you guys are in grade 10 and you struggle, some of you, with just simplifying, applying BEDMAS. Okay, and it shouldn't be the case. So please, let's get the simplification right. Let's calmly do the simplification in such a way that we are pleased with the work that we do. Are you with me? Okay, any questions about this question specifically? Any questions about this question? No questions. All right. Then I want to end on this note then, this beautiful note. Here we have a graph of f of x, which is a tan x. This is a trig function, a tan function. We don't know what the value of a is. So it's a tan x. And so this is f of x. And we can see f. So this is the trig function. And you can clearly see it is a tan graph, this one, because it has the mother shape of the tan graph. It is the same shape as the mother tan graph, actually, even. Okay. And let's look at g of x. G of x is equal to 2 cos x plus p. This here is our cos graph. And it has the value of a, it's 2, right? And we know that this 2 speaks to something that we refer to as the amplitude, right? The amplitude. 2 cos x plus p. Now, we are told that this is for x is an element. In other words, this function, it exists between 0 and 360 degrees. If you look at the function, look at it, there it is, from 0 all the way to what? To 360 degrees. it is basically only existing between 0 and 360. 360 being that last endpoint, right? And they were told they are sketched these functions below. So that's why you have these two functions represented. And even this cos graph, it basically resembles the mother graph, because the mother graph for cos starts at 1 like it does here, then it does this, it goes through this shape. Okay, now we are told here to use the graphs and the information provided to answer the following questions, and they are saying in 7.1, write down the values of A and P. A and P. Write them down, the values of A and P. Okay. So guys, the time now is exactly 2 o'clock, and I literally right now have to vamoose, right, at this very crucial time when I've basically just introduced or come into the introduction of these trig functions. So I'm going to leave it right here, and when I go live I'll pick it up from here, right? But yeah, it's beautiful trig, guys. Trigonometry has a lot of marks. Grade 11 it has a lot of marks. Grade 12 it has a lot of marks. So these are, I feel, easy marks that you can get. You know, do not let them pass by. You know, do not let these marks pass you by. Chow them. They need to be chowed by someone who is hungry to chow marks. Do not be chowed or cooked by these things. All right. Lerato. All right. Aike Sisi we nation, the lady of the nation. I see Lerato wants to save South Africa. I love this. I love the heart of salvific saving nation heart and mindset. All right, no, will do. But thank you guys, it was great, it was good. I hope you guys really gained something, and it, you know, has given you a bit of oomph and desire to go and you know, look at and practice, so that you can also landuka. Let's see the rest of this paper. Oh, there's some geometry there. I see some geometry there in the diagram below, the diagonals of a rhombus. A, B, C, D intersected O. You see, that's another thing. Geometry needs you to know the properties of all of your quadrilaterals. Not only quadrilaterals, but even all the things that have established in earlier grades. The theorems that have established, the axioms, angles on a straight line, vertically opposite angles, congruency. It needs you to know all of those things very well. Sum of angles in a triangle, angles opposite equal sides for isosceles triangle. You need to know all of these things very well, so that when you come here, it's just mincemeat and child's play for you. You can chow everything, be the chow man, or the chow girl, or the chow guy, or chow whatever. You know, look, you need to understand the guide, the properties of the guide. When you do, so easy to answer the questions, get the values, the angles. It's a piece of cake. You know, got a square there. You know, hey bana, proving. You know, QSN, certain angle is equal to another when there's no numerical values. Now, proof type questions. So this was a nice paper for the kids of that year. It was a paper out of 100. It had both paper 1 aspect topics, and then it transitioned to paper 2 aspect topics. You can see what's there, your linear functions for algebra, number patterns at that time, you know, algebra, you know, expressions, factorization, exponents. Yeah, So this was a paper written when 2022, grade 10. Yeah, common test. Yeah, so 2022, those who are eager to find the paper, it was a what? KwaZulu-Natal, the province, 2022, guys. I'm sure you guys can find it. All right. Those who are like, send me the paper. Send yourself the paper. Go find it. Thank you so much, guys. I love you a lot. You guys are loved by me. You know, when a person sacrifices their time and sets that aside for the purpose of helping people with math during this time, these early hours of the morning, you must know there's love. People like, I mean, why would I do it? I do it because there's money. No, there's more money. You can see there's no money. Even you can see there's no money. Am I doing it for popularity? What popularity? For the who? You know, it's 2 o'clock in the morning. I'm up helping with maths. You know, there's no money, no nothing, just helping. So yeah, I hope you guys really can benefit and you apply what you learned today. Thank you so much, guys. It was great. Have a good night, and till we meet again.